So this is HPLC, and this is what most of the Year 12 stuff is about. And this is where we take our theory of chromatography that we learned in our paper chromatography, start to apply it here. Instead of just some paper, we've got a column of our stationary phase, which is packed with some gel or some silica stuff that basically acts as our stationary phase. Our solvent, our mobile phase, is under high pressure and it's pushing through this thing here. If we take our example of our chromatograph here, all we need to do is lie it flat like this to understand how HPLC works. These solvent, the mobile phase, comes into our column. Our sample is put at one end of the column, and then as it moves through our stationary phase, it starts to separate out. When it comes out of the column, it goes into a computer called a detector, or I think there's actually detectors before the computer, but the idea it goes into a detector, and you end up with a peak when each substance comes out. So let's say that this blue thing comes through, you end up with a peak for the blue stuff. After a while, then all of this pink stuff will come through and you'll end up with another peak for the pink stuff here. This time that it takes to go through our column is pretty much unique for each compound, so therefore it can be used to identify the compound. That's called the RT time, and that is what you use to find the identity of our compounds. The size of the peak, obviously the bigger the peak, the more stuff's there. So we can use the size of our peak using a calibration curve to find how much stuff's there as well. But this is the idea. If you know paper chromatography, that most people are pretty familiar with, all you need to do is turn it to the side and you can understand how HPLC works.